Okay, so law of large numbers. Okay, this is something that you see a lot with the empirical rule. Okay, so basically what it says is as an experiment is repeated, over and over, the empirical probability of an event occurring reaches the theoretical probability. So normally when you're all in class, we do this project where you flip a coin. Okay, you all flip a coin 10 times. The classical probability or the theoretical probability of flipping a coin and getting heads would be what?
1/2.
50%, 1/2, right? Okay, but what if you get tails the first time? That means your probability is 0, right? But the more times you do it, and we take everyone's results and we calculate it, the probability gets closer and closer to 1/2, okay? So if you just do it by yourself, there's a chance you're gonna get 0. If you do it 10 times, there's a chance you're gonna get like 4 out of 10. But as we increase the number of times we try that, it gets closer and closer to that 1/2. So that's the law of large numbers. It also goes with the idea that the larger the sample size, the better the data. Okay, so that's what that's talking about. All right, classifying top types of probability. So classify each statement as an example of classical or theoretical, whichever one you want to call it, empirical or subjective. So the probability that you'll get an A on your next test is 0.9. This is going to be subjective because you're guessing. It's kind of like saying there's a 50% chance of rain tomorrow. You're guessing that that's going to happen. Okay, it's an educated guess. The probability that a voter chosen at random will be younger than 35 years old is 0.3. Okay, this is empirical probability. And that's because the info collected from a survey. Yeah, there's no way to really, not everyone has an equal chance of being chosen. Okay. The probability of winning a 1,000 ticket raffle with one ticket is what? That's your classical or your theoretical. Because every ticket has an equal chance of getting drawn. Ooh. Equally likely to be chosen.
So classical and empirical are based off of like surveys, and then
Empirical is based off of like a survey, a graph, data that's already been previously collected.
yeah, and then classical is kind of the same way, but like everybody's equal.
Everyone's equal. Yep.
And then just subjective.
Yes, correct. Okay, so then we finished up that one last class. Okay, so 3.2, looking at conditional probability in the multiplication rule. Okay, so conditional probability is when two events have happened and the first one could be affecting it. Okay. So these were all done on the video. Okay, independent and dependent. Okay, we talked about the fact that dependent is when the result or that probability is affected by the first event. So we're looking at page 8 on the bottom. So if we toss a coin and we get a head, and then we roll a dice and get a 6, are those two events dependent of each other? No. Okay, so these are independent events. Because rolling a 6 is not dependent on flipping a head. Driving over 85 miles per hour and getting in a car accident. Those are dependent. I'm starting to fall off my table here. Okay, because driving 85 miles per hour, you have less control. And can wreck easier. Okay. The explanation part's gonna be a little different for each of you, and that's fine. Okay, so then remember, the multiplication rule says we have to bring in that conditional probability. So if the probability of A and B equals the probability of A times the probability of B given A. So you are multiplying, but we have to take into consideration, did A affect B? Okay, and we looked at this with the probability of getting a king and a queen, and without replacing that first card, it lowered the amount of cards in the deck, okay, which is what made it dependent. Then we looked at the flipping a coin, rolling a 6, those are independent, so we didn't have to change anything about our second fraction, okay? Something else with multiplication is we can use it to find various probabilities. So for ACL reconstructive surgery, the probability that the surgery is successful is 0.95, so 95%. Find the probability that 3 surgeries are successful. Okay, so if we want to find the probability of 3 successes, okay, the first success has nothing to do with the second because they're usually 2 different patients. Okay, so we can just simply multiply all of these together. So 0.95 times 0.95 times 0.95, or cubed. Okay. And if you multiply that all together, you get 0.857. Okay. Find the probability that none of the surgeries are successful. That means you would have 3 failures. Okay. So first we need to start off with finding the probability of 1 failure, which means we're going to find the complement. So how do you find the complement?
1 minus 0.95.
1 minus 0.95, which would be 0.05. Okay. So now the probability of 3 failures we're taking 0.05 times itself 3 times. And this is a situation where you're gonna have to write more than just 3 decimal places. Okay, so if you plug this in your calculator, you're gonna get 0.000125. Okay, so situations like that, I want you to go ahead and go till you get 3 digits. Okay, on your homework, it's going to tell you what to round to. So it might say round to 6 decimal places. Okay, so make sure you're being careful in reading that. Okay. Okay, find the probability that at least one of the 3 ACL surgeries is successful. So if we're finding the probability of at least one, that could be 1, 2, 3, and keep adding all the way up. Okay, we'll talk about how to find that in chapter 4. For what we're going to do is we're going to do the complement. So we're going to say 1 minus the probability of 3 failures. Okay. Rather than having to add them all up, if we find the complement, 1 minus 0.000125, which equals 0.999875. I'm okay with you leaving that to 6 decimal places based off your previous answer. Because otherwise, if you rounded that, it would just be 1. And we know it's not 100%. It's slightly under. Okay. Okay, now we have this idea of unusual events. Okay. An unusual event is any probability less than 5%, so 0.05. So are any of those probabilities we just found unusual? Yes. Three failures is unusual, which is a good thing because you want to have success with surgeries. Okay, questions with that application of the multiplication rule? All right, last example. In a recent year, there were 18,187 United States allopathic medical school seniors who applied to residency programs and submitted their residency program choices. Of these seniors, 17,057 were matched with residency positions, with about 79.2% getting one of their top 3 choices. Medical students rank the residency programs in their order of preference, and program directors in the United States rank their students. The term match refers to the process whereby a student's preference list and a program director's preference list overlap, resulting in the placement of the student in a residency position. So we want to start off with find the probability that a randomly selected senior was matched with a residency position and it was one of the senior's top 3 choices. Okay, so we want to start off with finding the probability that they matched. Okay. So how many seniors are matched?
17,057.
17,057 out of the total of 18,187. Okay, if you divide that, you get approximately 0.938. Okay. So now we want to find the probability that they matched, and it was the top 3 choices. So we can bring down our probability for matched, 0.938. And then what's the probability that they matched given it was one of their top 3 choices?
0.792.
Correct. So 79.2%, which we changed to a decimal, 0.792. Okay. Then if we multiply those and round, we get 0.743. Okay, part 2. Find the probability that a randomly selected senior who was matched with a residency position did not get matched with one of the senior's top 3 choices. Okay, so let's start off with finding the probability of not top 3. Okay, so if it's not in the top 3, we're going to do 1 minus what?
0.792.
Correct, 0.792, which equals 0.208. And then we're taking the probability of matched and not top 3. Which means we're multiplying 0.938 times 0.208. Which equals 0.195. Okay. So would it be unusual for a randomly selected senior to match with a residency position and that it was one of their senior's top 3 choices?
No,
No, why not?
because it's not under 0.05.
Correct. Because the probability is not less than 0.05. Okay, so you have homework from 3.2 by Math Lab, and then you have a 3.3 ed puzzle, and it's short, it's under 10 minutes. I don't remember how long it was. I recorded too many things this morning. Okay, but it's under 10 minutes. Actually, I want to say it's like 6 minutes long, 6.5. Okay, you also have a week 4 reflection. Okay, so you guys, I'll remind you after lunch. When you guys get off Zoom, do your week 4 reflection first before you forget, because most of you are not getting them done. Okay. Also,